research question is it possible to produce a simple framework for investigating family inheritance without the need for genetic testing? This simplifies the following aim: to find my chances of inheriting a faulty cholesterol gene without doing a genetic test. For 3 generations, the fathers in my family have died from heart attacks, probably due to a gene that causes the body to produce huge amounts of cholesterol. My father is still alive, but he takes a drug called a statin to lower his cholesterol levels. It is possible that if this drug was around in the 20th century, these men would have not died in middle age. Other members of the extended family also have a cholesterol problem. It would be easy enough to have a genetic test to find out if I have this faulty gene, and this is the future. But for now, there are problems with this emerging science, which, although it can tell you if a faulty gene are present, it still only gives you the probability that you'll develop this condition in the future. So, problems arising from genetic tests are: insurance companies can discriminate against you because they can take the results as absolute and not a probability. Finding out other conditions you didn't know which may be life-limiting. Realising that you've inherited something that other family members should also be told about, and therefore creating an ethical dilemma for you. And paternity surprises. It was reported in the news last month that 10% of people who have taken a genetic test find that they're not related to their father. In order to collect primary data, I decided what information I needed to construct a genetic inheritance diagram and wrote a questionnaire to ask the relatives. As this is a sensitive issue, after all, brothers, fathers and grandfathers have died of the problem, I had a meeting with a genetic counsellor to look at the ethical considerations of asking sensitive questions. My relatives were happy to talk to me, and I collected a huge amount of information. This is my genetic family tree. These 3 grandfathers died of a heart attack, and this is my father who is on statins to lower cholesterol. All these other members of the family also have a cholesterol problem. I also found out there was a family problem with the thyroid gland, which seems to be introduced into my family via my great-grandmother. My great-aunts and uncle have both conditions, and other members of the family also have a faulty thyroid gland. This is relevant to mention here because I found a research paper that suggests thyroxine, the drug given for the thyroid condition, may lower cholesterol levels. My aim was to find out my chances of inheriting a faulty cholesterol gene without doing a genetic test. I'm confident that I've successfully fulfilled this aim. The pattern of inheritance through the generations of the faulty cholesterol gene fits the pattern that suggests only 1 copy of the gene is needed for the condition. My great-aunts are living with faulty cholesterol gene but have not died young. They have been on medication for a faulty thyroid gland for years, and it is possible that this medication has kept their cholesterol to manageable levels. I've worked out that I have a 50% of inheriting a faulty cholesterol gene. When combined with a thyroid gland problem, I have a 3 out of 8 chance of inheriting high cholesterol and a normal thyroid function, or a normal cholesterol and normal thyroid function, if my father is a carrier of the faulty thyroid gene. As neither of my parents have thyroid gland problems, I don't think that I'm at risk of inheriting this problem, although I may have inherited 1 copy of the gene without any symptoms, and it could be passed down to my children. All these conditions have not shown up in my family until they're in their late 20s and early 30s. Until then, I'm going to be proactive and ensure that my cholesterol levels and thyroid glands are checked regularly. I think that my results have given me enough information so I don't need a genetic test. Evaluating my journey, it was a challenge to sort out all the information I collected from my relatives, as they were happy to tell me all their medical problems, and I had to keep them focused on the cholesterol problem. I was lucky to have such a cooperative family, and this approach would not work if someone didn't have access to their biological family, or have uncooperative relatives, or simply not enough members of the family to be statistically significant. Thank you for listening.
You raised an excellent point about insurance companies, and you said that they treat it as 100%, you have some genetic marker and they treat it as a definite thing rather than probability, and they might even refuse your insurance. But even if they don't treat it as definite, they're treating it as something that increases your likelihood of getting some medical ailment. They can raise your insurance premium. So it could have effects even if the insurance company is treating it correctly as a probability. That's an excellent point about genetic screening.
How do you think the Human Genome Project has possibly will affect your family in the future, the research that's done by that?
It could potentially help with getting specific medicines to cure specific diseases. So if you, like for some breast cancers, if you know the sequence of which gene the breast cancer is, there's specific drugs that be given depending on what type of breast cancer you have. So potentially you could have personalised medicine to whatever disease you have if you know what the sequence of the disease you actually have.
Okay, I'm afraid that's all we have time for at the moment, but I'd like to say thank you very much to our speakers again. You can... Okay.